Alright, so we're continuing where we left off. Just to remind us where we are here, we've got the equilibrium solutions for the predator-prey equation. And so now we're going to linearize the system and analyze the system at each of the equilibria. So let's go ahead and do that then. So to linearize the system, we need the Jacobian matrix. And so maybe I'll take a look at these while we're here. Oops. So the f sub x is going to be 3 minus 2x minus y. F sub y will be minus x. G sub x will be y. And g sub y will be 1 minus 2y plus x. Good. And now we're going to plug things in to our 4 equilibrium solutions and see what we get. So at the origin, that's the easiest one, we get 3, 0, 0, 1. Okay, so that is going to be a source. We could go ahead and figure that out using the Poincare classification, but with 2 positive real eigenvalues, you get a source. Okay, and so let's take the next point then. At 0, 1, we're going to have, let's see, 2, 0, 1, minus 1. Okay, and so the trace is going to be 2 minus 1, which is 1. Determinant is minus 2, just minus 2. So if the determinant is negative, you don't actually have to get the discriminant because this is a saddle. Okay, let's go to the next one. At 3, 0, we get minus 3, 0, 4. And this is another one of these diagonal matrices. Although we could do the trace discriminant thing, we see here that our eigenvalues are going to be real and mixed, so therefore we have a saddle. Okay, and then the last one is at 1, 2, and there we have a minus 1, 2, minus 2. Okay, and so from here we'll go ahead and do our trace. Trace is going to be minus 3, it looks like. Determinant will be 2 minus 2, which is 4. And so the discriminant is going to be 9 minus 16, right? And so that is going to be a negative number. And so where are you in the Poincare classification? If the trace is negative and the determinant is positive, right, that puts you in this quadrant. And so then when the discriminant is also negative, that puts us right in here. And so we're expecting a spiral sink. Good. So we have a source, 2 saddles, and a sink. And let's see how that works. So if we go to our online graph, we can kind of take a look at it. Okay, and so here's the online graph. And so you can see here where are the 4 equilibrium. There's one at 0, 0. There's one at 0, 1. There's one at 3, 0. I think you can probably see them here. And then there's one at 1, 2. Good. And so what did we have for these? This was a source, and you can see the source, I think, pretty clearly. This one, can you kind of see the saddle taking shape here and here? So that was a saddle. Okay, this is also a saddle. You can see the shape in there taking form. Along the axis here, it was going towards the origin. Okay, And then you can see that was stretching out away. Good. And then finally, we see that at 2, 0, we're getting a spiral in, right? Beautiful. So, although this is mathematically nice to see the entire screen, in terms of the model itself, right, we're really just looking at the first quadrant because this is a population model. Okay, and so what is our conclusion about this population model then? Well, unless you're right on what we call the stable manifold here. Oh, I guess the stable manifold's on the axis. So that would zero out one of the populations, right? So as long as you're not on one of the axes, it looks like every other population will move towards this equilibrium at 1, 2. Good. And so that's kind of a balance of nature, right? The predators and preys are living in some kind of balance there. All right. So that is the predator-prey example. We're going to take a look at another example later. But for now, that's it.